Okay, so in this video, I'm basically going to show you how you transpose a matrix. Let's say that A is given by A, B, C, D, E, F. Let's say we have this 2 by 3 matrix here, and we want to transpose this matrix. Usually, we just denote it with to the power T. That's how you'll know that this just means A transpose, or you just transpose matrix T, matrix A. So now, if you are transposing this matrix, the rule is basically simple. You're just gonna remember this is your row. You're just gonna replace this row with every row must become a column, and every column must become the row. That's just the rule. So now you have row ABC. So now you must have column ABC. And now you have row DEF. That means you must have column DEF. And that's just the transpose of that matrix. So a 2 by 3 matrix, the transpose of that is going to be a 3 by 2 matrix. Basically, it's just that you just switch the columns and the rows. But now, if you have matrices like this, which are not square matrices, that means like the basic idea is this one, that the rows and columns switch. But if you have a square matrix, like this, let's say 1, 0, 5, 3, 2, 1, and then 3, 5, 5. Let's say we have this matrix. So now a transpose of this matrix, you're just basically gonna, since it's a square matrix, it's safe to say that you're just gonna reflect along the main diagonal like this. So remember, this is your main diagonal, 1, 2, 5, like this. The diagonal must stay the same. So A transpose, you just keep the diagonal the same. So you have my diagonal 1, 2, 5. And then what you do is like you swap. Now, you reflect along the main diagonal. So that means that you're just gonna have something like this. 0 and 3 will 0 and 3 will switch positions, and then 5 and 3 will also switch positions. And then, so you're just going to have 3 here, and then you're going to have 0 here, and then you're going to have 5 here, and then you're going to have 3 there. So you're going to have 1, 3, 3 as your first row. Remember, it's still the same thing here. Remember, this was the column, and now it becomes the row. And this was the row, and now this was the column, it became the row. And this was the row, and now it became the column. So that's just the basic idea there. So now, okay, so it still applies. Here you'll just trade 1 and that 5 there. So that means you're just basically going to have a 5 here and then 1 here. So you see, it's just the reflection along the main diagonal, really. So it's that simple. Or if the main diagonal reflection is kind of confusing, just replace this column and make it a row, and then take this column and make it a row, and then take this column and make it a row. Then you're done. Then that's just the transpose of a matrix. So now, let's try another example. Let's say A is equals to 3, 5, 5, 5, or 5, 5, like this. Okay, 5, 5, like this. Now we want to transpose this matrix. So how are we going to do that? So it's basically simple, really. So, okay, A to the T. So you just swap, you reflect along the main diagonal. Since it's a square matrix, so you're just going to have something like this. So now notice that it's still going to be the same, since like the 5s are just the same. You still have the same numbers here. So that's just going to be the same matrix, even if you transpose it. So now, why do we need to transpose this? Remember I showed you the rule for like finding the inverse of a 2 by 2 matrix. If you recall correctly, you have A, B, C, D, and then what you do, what I said is like the A inverse will be 1 over the determinant of A, and then multiply that with, you just switch this, and then you have D, and then you have A, and then this one swap signs, minus C, something like this. But now we're gonna we're gonna transpose the matrix, and then do a further manipulation, and then find the inverse of a 3 by 3 matrix. Or we can even escalate that further to even a 4 by 4. But I'm just quickly gonna just do a 3 by 3 in the next video. Thanks for watching. Don't forget to share and subscribe.